So welcome to another Advanced Higher Chemistry video on inorganic chemistry, so Unit 1. And this video is going to be one of the longer ones because we're going to go into the rules for naming transition metal complexes. Annoyingly, naming a transition metal complex is only worth 1 mark in the final test. However, it always comes up and it is a really important skill to have because it does help you when it comes to reading other questions. So we're going to look at the different aspects and rules for naming transition metal complexes. So there are going to be 5 parts to naming complexes. The first rule is going to only be applicable when the transition metal complex is part of a compound. So transition metal complexes can either be positively charged, neutral, or negatively charged. If a transition metal complex is positively charged, to make it a compound, it's going to need some negative ions bonded to it to make it neutral. If that's the case, you're going to put the name of the positive ion, the transition metal complex, before the names of the negative ion. If your transition metal complex is negatively charged, it's going to need positive ions to balance it out. If that's the situation, you put the name of the positive ions before the name of the transition metal complex. In many situations, you're only given the transition metal complex with a charge as an ion. And if that's the case, you ignore this first rule because that only is applicable to when the complex is part of a compound. The second rule is going to be related to naming the ligands. So each ligand gets a slightly adapted name that describes it being part of a transition metal complex and not being an ion or a molecule on its own. The second thing is that depending on how many of each ligand there is, you're going to need to use a prefix to describe how many there are of each ligand. The fourth part is the name of the metal. Now this is frustrating because the name of the metal will slightly change depending on whether the complex, the transition metal complex, is overall positive, overall neutral, or overall negative. And the final thing is you will need to include the oxidation state of the metal in the form of a Roman numeral after the name of the metal, as you've seen in other transition metal complexes, such as iron 2 chloride or iron 3 chloride. You're going to need to do that. So for each transition metal complex, you'll need to work out the oxidation state and then include it in brackets. So we're going to go through each of these rules in turn, and then there will be some examples. So here is one example. We have cobalt, we have 2 waters, we have 4 chlorines, and it has an overall negative charge. Now, water gets turned into aqua, chloride gets turned into chlorido, and cobalt gets turned into cobalt-8 because this complex has a negative charge. So you're going to need to learn how to apply the rules to be able to name a complex such as that one shown there. Don't worry, we'll go through it step by step. So you should, in your summary notes, have all of these rules written down, and it is important that you look over them. But every ligand has a slightly different name when it goes into a formula. So the first ones that I want you to focus on are chloride, cyanide, hydroxide, oxalate, and oxide. These are all negatively charged ions. And if you look for every single one of these, the only thing that changes is the last letter. Chloride becomes chlorido. The same would happen for fluoride to fluorido, bromide to bromido, cyanide, cyanido, oxalate to oxalato or oxalato, and oxide to oxido. If it is a negatively charged ion, you change the name by changing the E at the end to an O. That leaves us only 3 other ligands. Water, which is aqua, and that's relatively straightforward. Ammonia is amine. Now, it's really, really important that you use the double M in amine. If you use a single M, it would be amine, and amines are going to be a new homologous series you learn in Unit 2. So you need to spell it correctly so that there's no ambiguity. It has to be amine for ammonia. And then carbon monoxide, which is a rarer one to show up, but carbon monoxide turns into carbonyl. Now, when you're putting the ligands in the name of the transition metal complex, you are going to label them in alphabetical order. So if you have cyanide and you have water, aqua comes before cyanido, so it will be aqua cyanido. The other thing is that the whole word gets run together. So if you had one water, one ammonia, one chloride, one cyanide, one hydroxide, it would be aqua amine chlorido cyanido hydroxido. All one word, no spaces. You're not going to get penalized for spaces, you just don't need them. Next thing is prefixes. Now, the prefixes are slightly different to some of the prefixes you've used in the past. It's unlikely that you will see one, but if there is one, it will just be mono. Typically, you will see 2 or 4 of a given ligand. And 2 is di, 3 is tri, 4 is tetra, and then you've got penta and hexa as they would normally be. Now, when it comes to putting your ligands in alphabetical order, just like when it came to naming organic molecules in Unit 2 in National 5 and higher, the prefix doesn't matter. It is the ligand name that goes in alphabetical order. So if you had 2 cyanide ligands and 3 water ligands, it is still going to be tri-aqua di-cyanido because aqua is A and comes before cyanido C. Also, if you had, for example, tetraamine, you need to put a double A in it. So hexaaqua, not hexaqua. You need the double A. So transition metal complexes, when written down in words, do not look very nice. Our third thing is naming the metal. Now, when it comes to naming the metal, you only need to worry if the overall complex is negatively charged. So if the complex is overall positively charged or is neutral, the metal just keeps its name. So aluminium stays aluminium, iron stays iron, etc. If, however, the overall complex has a negative charge, the name of the metal ends in ATE. So, for example, if your normal metal ends in IUM, you change IUM to ATE. Vanadium, vanadate or vanadate. Chromium, chromate. If the metal doesn't have an IUM, you're typically adding ATE, for example, cobaltate. Now, there are 3 exceptions because, of course, we can't make anything easy. Iron, cobalt, and lead. However, the main 2 that you'll see are iron and cobalt. When they are involved in negative complexes, iron goes back to its Latin name, which is where we get the symbol Fe for iron. It becomes ferrate. Copper goes again back to its Latin name, which is cuprum, and it becomes cuprate. Lead again goes back to its Latin name, plumbum, and becomes plumbate, which again is where we get the PB4. I know this is really annoying, but they definitely like to throw in an example of either iron or copper, just see. But remember that rule only applies when it is negatively charged. If the complex is overall positively charged, the metal name just stays exactly as it is. Fourth part, oxidation state of the metal. So you know the rules for working out the oxidation number. The overall charge of the complex is equal to the individual oxidation states or charges of everything inside of it. So you can use that to work out the charge on the oxidation metal, and you'll just use your Roman numerals. The Roman numerals always go in a rounded bracket after the name of the metal. So copper 2 or ferrate 3. And finally, if the complex is part of a salt or if it's part of a compound, you need to look at the complex. Oh, I don't know what's happened here. My pen. But if it's part of a complex, so here, sodium has come first. If it's part of a charge complex to work in the oxidation number, we've got 2 sodiums, but that means they are contributing 2+, and it means that your complex must have a charge of -2. And then you can work out the charge of the transition metal once you know the charge of the complex. And again, in this, the complex has a charge of -2, which is why it comes after the positive ions. And because the positive ions come first, it means sodium goes in front of the name of the transition metal complex. So this transition metal complex, it has 4 cyanides, so it will be tetracyanide. It is negatively charged, so copper changes its name to cuprate. And when we work out the oxidation state, we know that copper is in a +2 oxidation state, so it is tetracyanide cuprate 2. If we're including the sodiums, those are going at the start. So we've got 2 examples here that we're going to go through. So this first one, we're going to first look what's coming first. Well, sodium's drawn first and it's positive charge. So we know it's going to start with sodium because it's positive, and then the transition metal complex is going to come second. We can also work out that it must have a charge of -1 because sodium is +1. Okay, that's our first rule. So we know sodium is going to be the first thing in the name, then the name of the transition metal. We're going to then look at our ligands. We have got ammonia and we have got cyanide. So this is amine and this is cyanido. And this one's going to be first, this one's going to be second, because amine comes before cyanido. We know that we've got 2 of these, so this is going to be di. We've got 4 of these, so this one's going to be tetra. So it's going to be diamine tetracyanide. The charge is -1, so that means our iron needs to change its name. Our iron needs to change its name to ferrate. And then we can work out our oxidation state. So our iron plus ammonia is neutral, so +0. Cyanide is a -1, and we've got 4 of them, so -4 equals -1, the overall charge, which means that iron equals +3. So when we put all of that together, it should be sodium. We leave a space because we leave space between the ions. Then it's going to be diamine tetracyanide ferrate. Then we open our curly brackets, put in I, because that's what 3 plus is, close those. Sodium diamine tetracyanidoferrate 3. Our next one. Right, this one. We've got our transition metal complex first, and then we've got chlorine. Chlorine is negatively charged. So that's each one of those is -1, which means that our overall complex has a charge of +2. We know the name of the complex is going to come before the name of the negative ion, positive before negative. So it's going to start with the complex and it's going to end with chloride. Next thing we do, look at our ligands. Well, we only have ammonia, which is amine. We have 6 of them, so that is hexa. Next thing, right, okay, we look at our metal and we look at the charge of the complex. Right, our complex is positively charged, so we do not change the name of the metal. Now what we need to do is work out the oxidation state. Well, copper plus ammonia is a neutral molecule, plus 0 gives us 2 plus. So copper is 2 plus, and in Roman numerals that is I. So the next one is going to be hexaamine copper in brackets with a Roman numerals 2 chloride. Hexaamine copper 2 chloride. So I know that is quite a lot to remember, but it is an important skill to look over. Please, if you have any questions or want any more practice ones to do, just come and see me. Final thing I need to say on this is a bit of an annoying fact for you, is that the rules for the names of transition metal complexes changed around, I don't know when they changed in the scientific community, but in the SQA, they changed around 2018, which means lots of past papers will have different rules for naming transition metal complexes. The main changes will be the names of the ligands. You won't see things like chlorido, cyanido, you'll see chloro, cyano, and things like that. So when it comes to naming these, it is best if you come to me and get your practice questions rather than looking past papers, because a lot of the naming conventions did change, and for that I can only apologise and say that I can definitely give you some examples to work on.